So here we observe the first chromosome, and we see that it has the arrangement of L, M, I, J, K, H, G loci. And so here is a different pictorial representation of the chromosome. Here is the actual representation. So if we were to introduce another chromosome that's MLKJIHG, we see that there is a pericentric inversion with the I, J, and K loci. That just means there's an inversion where the loci are switched that include the centromere. So if we were to cross these two, then it would have to become oriented in a way where the loci are lined up together. But because there's an inversion, it has to be oriented in a specific way. And so this is how it will look like. As you can see, even though they're inverted, the three loci in the middle are still lined up, and so they are able to pair with each other. And here's a better representation of that orientation. So if there were to be a crossover event between the J and the K loci, then you would have four different chromatids that would occur from that. So for the first one, it would just be the MLIJKHG, and because there is no crossover occurring on this specific chromatid, it would just be the same as the first parent chromosome. But for this one, because there is a crossover event occurring with that chromatid, it would cross over after the J into the K of the second chromosome's chromatid. So it would have the MLKJI and a repeat of the L and M locus. Now this would not be viable because there are repeats of specific loci, the M and the L, and they are missing the H and G loci. So therefore, this is not viable. The third way would be the same as the first way, where there is no crossover occurring, and so therefore it would just be the same as the second chromosome chromatid. Now this one, because there is a crossover event happening at the J and K, you would have a GHK, ordered loci where there are repeats of the G and H loci, and you're missing the M and L. So therefore, this would be a non-viable chromatid. And so let's say we have another chromosome pairing where we have a MLIJKHG and a GHKJILM, so backwards of each other. Now, this doesn't really have a big difference because there is no inversion happening. The chromosomes are simply just backwards. Now, this doesn't change the chromosome at all. If we just turn it back around, it will be the exact same chromosome as the first one. And so if you were to cross those, you would have four different chromatid possibilities, and they would look exactly the same because no matter which way you go with the crossover between the J and K, it would have the same. It would all be MLIJKHG. Now, if you're observing the fitness level between the very first cross we did with the inversion and the second cross with no aberration in the chromosomes, we will find that the second one would actually be more fit because all the chromosomes are viable, whereas in the first cross, only two were viable.